Geographic Information System is a useful tool in land use and land cover mapping to improve sustainable development, especially in urban, agricultural, and industrial areas. The Land Use Changes maps produced by GIS can be used to compare primary data between specified time periods to detect land use changes. By using land use or cover mapping, urban, agricultural, and industrial areas of cities can be more effectively chosen and selected. Using remotely sensed data has enabled quick, accurate, and low-cost examination of changes taking place on land. In this study, the land use changes in Alor Gadja, Malacca have been compared between 2015 and 2021. The resulted maps can be used as a guide for sustainable development. Changes in land use and land cover are a significant instrument for evaluating spatial changes at different time scales. Recently, land use and land cover changes have been more impactful on ecosystem survival. Changes in the environment appear to be caused by human activity. Changes in land cover have a significant impact on the balance of water, energy, and geochemical parameters at various levels, and this ultimately affects the sustainability of environmental resources. Therefore, it is crucial to comprehend landscape patterns and the connection between human activities and the natural environment in order to make effective decisions in land use planning and management. To facilitate the process of identifying land use changes between two or more time intervals by the displayed results. To promote efficient land uses while preventing wasteful development. To reduce the cost of public services, infrastructure, and facilities. Let's have a look at the steps.
So let's start the tour. First, open the desktop file of the ArcGIS Pro version 3.0 software. To begin a new project in a new project file, click Start without a template. There will be a new project file added to the desktop. After that, insert a new Malaysian map and it will show up on the desktop. This region, Alor Gadja, Malacca, Malaysia, is the focus of investigation. After that, select Add Data from the menu under the Map button. In the Add Data appearance, select the entire raster dataset, which is in .img format. The raw data of numerous Landsat 8/9 OLI photos will eventually show on the screen after a little delay. Click the View button, then Geoprocessing Tools, then Data Management Tools, then Composite Bands. By combining different raster datasets, Composite Bands creates a single one. Insert Band 1 to 7 under Geoprocessing Composite Bands Tools. Utilize the Landsat 8/9 pictures as the input raster and look for the output in the Output Raster file. Composite Band is used to create the image, which appears on the screen. Click Geoprocessing Tools in the View button and then Spatial Analyst Tools, then select Extract by Mask. The Extract by Mask tool extracts the raster cells that match the areas specified by a mask. Insert the input raster and the input raster or feature mask data into the Extract by Mask tool, then find the Output Raster folder. Alor Gadja's image has now been extracted and displayed on the screen. Go to Image Classification in the Imagery button's Classification Wizard menu. In the Training Samples Manager, add additional classes for forests, built-up areas, agriculture, water bodies, open spaces, vegetation, and clouds. Create a few samples on top of the image in accordance with the classes established using the polygon and circle tools. Save the created training samples in the Output Location folder for storage. Choose Supervised as the classification method and Pixel-based as the classification type in the Image Classification Wizard. Save the output in the folder designated for outputs. Next, select Maximum Likelihood as the classifier. The performance of this classifier is predicated on the assumptions that Bayes' theorem and the cells in each class sample in the multidimensional space are normally distributed. The screen displays the classified raster preview. After that, use the Export Raster tools to export the classified raster. The Content menu then displayed the classified Alor Gadja 2015. Repeat the technique using a different satellite image from a different year. Create the final output of this product. Land Use Map of all Orgaja in year 2015 in Layout View. To compare and visualize the land use changes, repeat the processes to create the Land Use Map of all Orgaja in year 2021.